So yesterday we graphed using y equals mx plus b. So we rearranged the equations and we used the m and the b to graph the line. So this is the other way I'm going to show you guys how to graph a line. And on a quiz or a test, I will ask you to do both, because remember with domain and range, I just say find the domain and range and you can use whichever method you want. This is not the case for this, because both of these skills are different processes. So I will ask you sometimes to graph like I did yesterday, but there will be other times where I ask you to graph using x and y intercepts. And it's exactly how it sounds. Okay, so you will be finding the x-intercept where the graph will cross the x-axis, and then you'll be finding the y-intercept, which you do know one way to do that already, but I'm going to show you another way, which is actually easier to find where it crosses the y-axis. Okay, so just quickly, all you guys have to realize is to get an x-intercept, yes, it's where the graph crosses the x-axis is your x-intercept. And the thing that you guys need to know is an x-intercept, the output, the y value for an x-intercept is always 0, no matter what. If you plot a point anywhere on the x-axis, it's going to be a number, comma 0, a number, comma 0. So that's the algebra that we're going to do to get an x-intercept. We're going to let y equal 0, and then all we'll have left to solve for is the x, which will be specifically the x-intercept. Okay, and vice versa for the y-intercept. Okay, algebraically, if we just want to do a y-intercept and not look at anything else, every single ordered pair on the y-axis will have an x as 0 and then an output of whatever number for y. Okay, so to get a y-intercept, we're going to let x equal 0 in the equation. And by putting a 0 in the equation, does that actually make it nicer? Does that whole term just disappear if I times it by 0? Yes. Okay. So if that sounds confusing, watch what I mean. All right, so if I have, I'm not going to start with that one. I'm going to actually start with this one. Okay. So if you have this equation right here and I want to find the x-intercept, doesn't matter which one we do first. Okay, if I want to find the x-intercept, we're going to let y equal 0. And picture this, guys. If we let y equal 0, will the 3y term just disappear? Will that term disappear if I let the y equal 0? Do you guys, yes or no? What's 3 times 0? Does it disappear? Yeah, it does. So is that an minus 2x equals 9? Is that an easy equation to solve? That's your x-intercept. So just picture all you do to get your y-intercept, the x term disappears, right? You can just scratch it out and solve the equation that's left for y. If I want to do the y-intercept, guess what? Right? If I want to do the y-intercept, I cover up the x one, right? The x term, it disappears because I'm substituting a 0 into it, and I'm solving for 3y equals 9. So I'll write it all down and show you guys. Right, so to get my x-intercept, because I think of the ordered pair, guys, this is what we're picturing. To get the x-intercept, this is what I'm calculating. Oopsie, that's not a very good question mark, right? I'm trying to figure out my x-intercept, and that happens when y equals 0. So this is the unknown. We're trying to find that number. So we let y equal 0. So if we let y equal 0, it's like that whole term, right? So that 3 times 0, it erases. It's gone. Whoopsie, not the minus. Right? That whole first term disappears. Right? Because do you need to write a 0 when in an equation? No, it's just a placeholder. So the whole piece disappears. So again, in the notes, I don't want it to disappear because if somebody's looking from home, right? But this whole thing disappears. So then I'm solving 2x equals 9. That's a nice one-step equation, right? Divide both sides by -2. And then we have x equals -4.5. Because 9 divided by -2. So that is my x-intercept. We remember x-intercept is an ordered pair. If I asked you to graph this, you would plot approximately where negative 4.5 is on the x-axis. That's where your point would go. And then your y-intercept, right? We're going to let x equal 0. Right? So away we go. So again, you have your equation. You have a 3y minus 2x equals 9. Grab the equation that you're given. Bless you. Substitute the 0. And a lot of times when students start this, they literally, could you guys start, if I asked you for the y-intercept and solve it algebraically, could this technically be the first step you write down? Yeah, absolutely. I would accept that. You don't need to show me that you're substitute unless you want to. More work the better. But you guys always ask me what's the minimum amount you need to show me. If you start at this rectangle piece, the 3y equals 9, does that show me that you made the x term disappear? Which tells me you know that that's 0. It disappeared. That's the equation that you're solving, right? So that would be a fast way to get your y-intercept. And then you would solve that. So you would have to divide both sides by 3. Right? So then you would get y equals 9 divided by 3 is 3. That, again, is an ordered pair. Right? So that is your output piece. So then your y-intercept was 3. Your x-intercept was negative 4.5. Reason, guys, this is important, is this idea of substituting zeros in for x or y, depending on what intercept you want to find, works for any function, okay? So this idea will follow through to your grade 11 math and your grade 12 math, because we're going to move away from linear after 10C, right? We'll be doing radical functions, rational function, quadratic functions, a bunch of different functions. And I'll ask you, or your teacher at that point in time will still ask you, what is your x and y intercepts? This process of substituting 0 in works for all the functions, not just the linear ones, okay? So this algebra will trickle with you up through your other math courses. It's just, will the algebra look different if I give you a different function? Yes, that's the only change that's going to happen. But the idea of to get an x-intercept, you let y equal 0. That rule holds true for any function in the world, okay, if you're trying to get an x-intercept. And vice versa, if I ask you to get a y-intercept on any function, okay, you'll let x equal 0, put it in, and then follow the algebra to solve for y. But 10C level, we're just doing these functions, right? Linear functions, that's it for x and y intercepts. All right, so let's just work our way backwards. So this little guy here, again, to get my x-intercept, right, we're going to let y equal 0. So if we let y equal 0, the whole left-hand side is 0 now. So I have a little bit of algebra to do, because 4 times 0 is 0. So I have 0 equals 3x minus 12. So this one now is a two-step equation, right? Because you need to get x by itself. So I got to move the minus 12, and then I got to divide by 3. So let's do it in steps. So I have to get rid of the minus 12 because I need to isolate x. So 0 plus 12 is 12 equals 3x. And then I can divide both sides by what? Good. Perfect. 3. So 12 divided by 3 is 4. So again, if I asked you to graph, that's where your ordered pair would be. You would cross the x-axis, you go on the x-axis, you plot a point at 4. Right? We're getting there soon, but we're not doing it yet. So x-intercept was 4. Okay. And then our lovely y-intercept. So where this line is going to cross the y-axis is what we're doing now. So we'll let x equal 0. So again, letting x equal 0 is like taking your finger, putting it over the x, right? So the 3x term is gone, right? And you're solving for y equals negative 12. That's what we're going to be solving here in a second, right? Because again, you put the 0 in for x, that whole term disappears. And again, you don't have to write a 0 there because it's just a placeholder. So it literally can disappear in the equation. Gone. So what's left on that side is a minus 12. Please make sure, though, the minus on the 12 doesn't disappear. All the signs in front have to stay connected to their terms. So this one's a nice one-step equation. So divide by 4, divide by 4. So here we have a y-intercept of negative 3. So that would be our ordered pair if we were graphing them. And sometimes students write, well, do I have to write it as an ordered pair, Ms. Calvert, when you're just asking me for my x and y intercepts? You don't have to write it as an ordered pair, right? You could just write it like we did on the lines. The only reason why I'm writing it as ordered pairs is to really hit home that to get a y-intercept, you can clearly see with the y-intercepts that x is 0, right? For your x-intercepts, y is 0. That's why I keep writing it, so you guys see that every single time. The idea of x and y intercepts are about putting a 0 in for one of the variables. Right? All right, so last little guy here before we do some graphing. So this one, right, for this one, can I see what the y-intercept is very quickly? From what the work we did yesterday on y equals mx plus b? Yes. And again, the reason why the b value, when it's in this form, is the y-intercept, right, is because if I cover up the x term now, is that all I have left is the minus 16? Yeah, because if you put 0 in for x, it's just we never talked about it like that. We just were like, oh, if it's in y equals mx plus b, the b is the constant. It is because if you put 0 in for x now, the only thing that's left is the b value, which is why it's the y-intercept. Okay. All right, so still going to show the work to it. All right, so x-intercept, so y equals 0. So this one we have a tiny bit of work to do. All right, so take the 16 over, the minus 16 over. So we're trying to get x by itself. So you'll be tested on your algebra skills here, your basic ones. Then we'll divide both sides by 8. So it looks like our x-intercept is 2. So we'll throw that one here. And you guys know, and I know that you know, that y-intercept is negative 16. But I'm still going to show my work. So negative 16. Okay. All right. So this, again, can't stress enough. I know I say this a lot to you guys this year just because there's so many pieces that are important that I get you guys to really understand moving forward to your next level of math. So this is one of them. Okay. And again, hopefully it's not a hard, way complicated process, but it's still a process, right? Putting a 0 into an equation for either x or y, right, to me simplifies the equation for you. But again, either you'll have a one-step or two-step equation that you have to solve after. Okay. All right, so skipping example 2 for now, I want to go right to doing what we just did and doing the step further. So we'll go back to example 2 in a second. So here it says state the x-intercept and y-intercept and use them to graph each of the following linear functions. Okay, so finding the x and y-intercepts and then plotting them. So which one do you guys want to find first? Doesn't matter. Pick one, x or y. X, so if we do our x-intercept, And again, guys, are you getting this? That literally, if you're finding your x-intercept, are you guys all visualizing this now? If you're finding your x-intercept, that's just disappearing. So that's the equation you're solving. Okay. And vice versa, Artem. So again, I don't encourage you to do that because do you need that number again for the next one? So don't like completely cross it out. But that's what you're picturing, right? Is to get the x-intercept. You literally make the, wherever the y is, the y term, it disappears because it's setting equal to 0. So this will get me my x-intercept. Okay, we let y equal 0, so that term's gone. So we have a little bit of algebra to do, so let's get rid of the minus 18, take it to the other side. So we have a 3x equals positive 18. And then we're going to divide both sides by 3. So it looks like our x-intercept is 18 divided by 3 is 6. So let's go ahead and plot that little guy right now. So again, as an ordered pair, not that again that you have to write it as an ordered pair, but that's what it is as an ordered pair. So you go to your grid. On the x-axis, you find 6, right? So on the horizontal axis, that's your x-axis. Go on the x-axis, find where 6 is, put a point. There's your first point on the graph. So let's go back up. Now, we know that to find the y-intercept, again, hopefully you guys are picturing this, the y-intercept, this one disappears, right? Because that's where we're putting the 0 in. So I showed putting the 0 in example 1, right? So I'm skipping that step now, and I'm just writing what I have left when I put the 0 in. Right, so y-intercept, all I have left is when the x term disappears is 6y minus 18 equals 0. So now I have a two-step equation. So get rid of that 18. So now we have 6y equals positive 18. And then we'll divide both sides by 6. So y is going to equal 3. So, whoopsie. So 0, 3. So again, go to your graph, go to the y-axis, and put an old point at 3, 4 on the y-axis. Talked about this yesterday. All you need minimum is 2 points to graph a line. So we have 2 points. So please go through though, like don't stop there because this is what I don't want to see. You guys see a problem with that? Right? Because remember, yes, we use specifically those 2 points, but the graph doesn't end there, right? So just extend them a tiny bit and then put what on the ends? Arrows. You guys are perfect. Good. And again, if you want to extend it the whole grid, you can, but minimum, guys, extend it a tiny bit because you don't want to put arrows on the dots. That looks weird, right? So just extend the points a little bit and then throw your arrows on the ends. And you're done. Okay. Okay, so you guys go ahead. I'm going to just work behind you. So do this question, look up when you're done. Because the biggest thing with these guys is students don't struggle with the idea of X and Y intercepts. Where the mistakes come in that you have to be careful with is the signs, right? Students, when they move stuff over the equal sign, they forget to change their sign sometimes. So please, this one we don't have to move anything, so you're lucky. But just be cautious of your integers, right? And just approximate, because this one's going to be a decimal, just approximate where it is on the graph, right? It doesn't have to be perfect. So are we good with 4.8 being our x-intercept and -2 being our y? Everybody get the signs proper? So it's okay if you don't get exact integer values. The math led us to a decimal value, which is good. Just the only time I would mark it wrong is if you put the point between the two wrong numbers. Does that make sense? So as long as that point is between 4 and 5, it's good because you're approximating it anyway. The only way, like I said, that 4.8 would get marked wrong is if you accidentally put it between like a 5 and 6 or 3 and 4. It does have to be in this box here, right? Between the 4 and 5. That point has to be there somewhere. Okay. But again, I'm not too picky if it looks 4.3. It is what it is. It's not perfect. Like, obviously, I would like it closer to the 5 than the 4. But again, I'm not looking with the magnifying glass if it's like closer that way. Right. So you will, like I said, can't stress this enough, you will have a question on your summative assignments where it asks you to graph using slope-intercept form, which is y equals mx plus b, like you guys did yesterday. But then you will have questions where it says graph the line using x and y intercepts, right? So you will have to get efficient at both. All right, second last thing I want to do, these ones are really fast. You graphed these guys actually in grade 9. So these ones are x equal and y equal equations without any other variable. So these are one variable equations. Do you guys agree? Every other one we've done so far are two variable equations. So this little guy here, y plus 2 equals 0, I would rearrange that for y equals first. So if I bring the 2 over the equal sign, what kind of 2 does it become? Negative 2. So we're actually graphing y equals 2. Does anybody, y equals negative 2. Does anybody remember what those lines look like from grade 9? It's okay if you don't, but does anybody remember? Yeah, straight up and down, except, well, this one, because it's a y equals, it won't be straight up and down, but it'll be actually side by side. Okay. And the reason being, this one, hopefully domain and range, guys, helps you with this graph. If you don't remember it from grade 9, which is, I don't expect you to, but it's saying that the only y values that can occur are at negative 2. So if y equals negative 2, does it go through the y-axis at negative 2? Yeah. So it's basically saying the output is only negative 2. So if that's the case, it touches at negative 2 on the y-axis, and it goes straight across. So all y equal equations, guys, without an x, right, are slopes of 0. Because technically, guys, could I write this like this? Y equals 0x minus 2. Could I technically write it like that? I could. But to me, the 0 slope is a placeholder. You don't need to write that. It kind of disappears, right? And then all you have left is that minus 2. And if you forget, the calculator will graph y equals equations. So if you put in minus 2 into the calculator, if you have one, and it'll remind you. It's just a horizontal line through y equals negative 2. So you just plot your, think of this, it is a y-intercept. Only have a y-intercept, there's no x-intercept at negative 2. So you plot your point and then just run your line horizontal. So your y equal equations without an x basically are lines that have slopes of 0. And if we know that, you guys all pretty confident you know the next one now, right? So you guys have seen these in the domain questions, right? So this one is just basically it has an x-intercept, but no y-intercept. So this one has an x-intercept at 5, right? So it has an x-intercept at 5. And this one doesn't have a y term. So this is your undefined line. So it's a vertical. Your calculator can't graph this in the y equals space, but it can draw it. Not that you need to draw it, but if you're curious, if you wanted to graph both of them, you'd have to go into your draw feature, not distribution feature, your draw, and draw a vertical. Quit it. There we go. So draw vertical. Not that you guys have to do this on your calculator at all. And then it will head in there. So you have both of them on there. So these do show up. It's still part of the 10C curriculum. You did these in grade 9 too. They're not a huge focus at the 10C. We want lines that have some slopes, has x and y intercepts, but these do come in handy when we start doing parallel and perpendicular lines, right, in the near future. So just remember all y equals equations without an x, horizontal lines, because it has a slope of 0. All x equal equations without y's are your vertical lines. All right, and then last little, throw in a little word problem to give you some application. So this one just says a student council rents a portable dunk tank as a fundraising activity. Students pay for the chance to hit a target with the ball and dunk a teacher into a tank of water. The relationship between the number of balls thrown, x, and the profit, y, in dollars may be represented by the equation 3x minus 2y minus 600 equals 0. And it says rewrite the equation in slope intercept form. So I'm making you guys flip back to what we did yesterday. So if we rearrange this for y equals mx plus b, I want to do one movement first, guys. Are you guys okay with me just taking the minus 2y to this side? Right? So then I don't have to move two things, because our goal here, guys, is to get it to this form, y equals mx plus b. So let's move the minus 2y. So I have 3x minus 600 equals, because if I move it, it changes to a positive. Because remember, we're adding 2y, balancing. And then now we can divide everything by 2. So it looks like we have 3 over 2x minus 300 equals y. If you hate the y on the right-hand side, guys, technically, is this the same thing? Are those two things mean the same thing? Yeah. It doesn't matter which side you write it on, but it does matter when you move stuff that you change signs. But then when you're done, because technically you could say you moved everything back to the other side and then divided everything by -1. That's why the signs can stay. Okay. So then here, state the slope of the line. So this is technically would be better on yesterday's lesson, because we're we're going to look at the y-intercept, but we're not looking at the x-intercept, right? For B, we're looking at the slope, and then C, we're looking at the y-intercept. So the slope of this is 3 over 2, or better known as 1.5, either one of those. In this context, it's probably easier to look at it as 1.5. So what does the slope represent? So in this context, does anybody understand what the 1.5 represents? Since x represents what? Right. So x represents the number of balls thrown. So guess what the 1.5 represents? Yeah, the dollars. It's how much each ball. So if you want to throw a ball at the target to dunk a teacher, you would have to pay $1.50. So every ball thrown costs $1.50. So the cost of one ball, $1.50 every single time you throw a ball. And then the y-intercept in this situation is negative 300. And this represents, guess what? Because if we throw 0 balls, because remember y represents the profit in dollars. So we're starting at what? How much in the hole? Negative 300. Because if we throw 0 balls, right? If we throw 0 balls, the x piece would cover up. So we'd still be minus 300. So does it make sense we'd start in the negative? Yeah, because unless they gave us the dunk tank for free. So this obviously would be the rental charge, I'm assuming, right? So the negative 300 represents the rental fee, I'm assuming, right? How much they're charging for us to, or for the students or the school to have the dunk tank. So that would be a nice way to put it. Cost to rent the dunk tank. So that's why it's a minus 300, right? Because we have to give that cash away to the place, the rental place, and then we would have to sell so many balls to break even, and then obviously so many to start making a profit. And would that be a fair question for me to ask you guys? How many balls would we have to sell to break even? Yeah, that would be a fair question, because you would just set the equation equal to, if I wanted you guys to see how many balls you had to rent or sell to break even, you would let y equal 0, because we want break even means make no money, right? So then you would let y equal 0, and then you would solve for x. And you could set it in either one of them, right? You could set it equal to this y equals equation that we rearranged, or you could put it back into the original. It doesn't matter which equation, because they're equivalent, that you could use. But again, we'll do more of that stuff later in this chapter. So for that, we are good. So please, please, please make sure that you're done yesterday's y equals mx plus b, because that's an important form as well. And then work on your x and y intercept practice second. So make sure yesterday's is finished, then work on your lesson 2.